The derivative of a constant is always 0. It is always 0. Always. It's constant. What's the derivative? 0. So they like to write the notation. They like to write the notation like this. Remember, we can say that when they're asking for the derivative, sometimes they can just say it's d over dx. So on the derivative of some constant c, it's always 0. Always. If there's no variable and it's a constant, it's 0. So for example, if I have f of x equals 7, well, what's f prime of x? I guess it's 0. 7 is a constant. So the derivative of that is 0. Always 0. If it's a constant, 0. All right? The power rule. Do you see this face right here? This is the face that you're all going to make when we learn the power rule, because this takes the difference quotient right off the table. Are you ready? Write that down. I will explain in a second. If I want the derivative of some, I don't know, n, it might be some constant, times x raised to a power of n. All I need to do is multiply the front number by my exponent, whatever it was, and then subtract 1 from the exponent, and that's it. You multiply your coefficient by whatever your exponent is, and then you subtract 1 from your exponent, that becomes your new exponent. So for example, when I have 4x cubed, that would be tough to do with difference quotient. I'd have to put x plus h into x cubed minus f of x, which is this, all over h. I have to cube my x plus h, which is 1x cubed plus 3x squared h plus 3x h squared plus h cubed. Multiply them all by 4, so it's 4, 12, 12, and 4. Okay, and then you have to combine them, cross out, and be, you know what it would be? You get 12x squared. Do you want to know how I did that so fast? No, because I'm good at this. I take my exponent down out front and multiply that times my coefficient. And then I just subtract 1 from my exponent, and that is the derivative. You no longer have to do the difference quotient. No, that's for logs. So, 4 times 3 is 12, x. 3 minus 1 is 2. That's it. So I tell you what, without even writing this down, what's the derivative of 5x to the 4th? Can you imagine if you had to put that in a difference quotient and to do that out 4 times? That's done. There you go. Yeah, that's what I thought. Because you need to learn, you need to feel calculus from the inside. You need to cry a few nights in the fetal position. Okay? And don't forget, this would be what? Y prime, right? That's what I say the derivative. Look how easy that becomes. All right. Next.
Can we do that now from now on?
Yes, you can. Yes, you can, Matt. I expect you guys to do this from now on. Absolutely. We love this. See, that's the face happy you made right here. Whoa! Okay, yes.
That's for which one? That's for the...
No, you guys cannot throw water bottles at me. Now, the constant multiple rule. The constant multiple rule, okay? That just says that if I'm taking the derivative, okay, of some function, and c is a constant in front of it, right? I can take the constant out front separately, and then take the derivative of the function without the constant, and then multiply the constant times the derivative. Okay? So, I'm going to give you 2 examples. One is the one we just did. Okay? And then I'm going to give you an example of another one here. Okay? Let's take a look at this first example. We know this should already be what? 12x squared? Well, what we're saying here is besides the chain rule, I can take my constant, which is a 4, and bring that out front, and multiply it times the derivative of whatever x cubed is. So that would be 4 times, what's the derivative of x cubed? What we just did. 3x squared. What is 3x squared times 4? You can do that too. If it's all crazy and you want to just take the constants out, just to worry more about the variables, you can do that. And it comes in handy for things like this. This second one right here. We're going to learn something where we take the derivative of fractions easy. Okay? But isn't this the same thing as saying 1/4 times x to the 5th? It is. So then I can just say 1/4 times the derivative of x to the 5th. Now how easy to do the derivative of x to the 5th? Who can tell me what's the derivative of x to the 5th? 5x to the 4th. So now I have 1/4 times 5x to the 4th.
Oh, you just split them up.
Yes, and that will give me 5x to the 4th over 4. That would be a lot easier than using the quotient rule, which I will show you in a minute or two. All right? I mean, that's a lot easier than doing that difference quotient, isn't it?
Yeah.
It's a lot easier. But if you can handle the difference quotient, this is cake. All right? You need me to go back? You need some writing?
Yeah, just for
Okay, I'm going to go back in a second. All right. The sum indifference rule. That means if I'm taking the derivative of any two functions that you're either adding or subtracting them, I can just take the derivative of each one individually, like a string of derivatives. Okay? So if I have two functions, u and v, and I'm adding them, I want to find the derivative of u plus v. Well, I can find the derivative of u, and then add that to whatever the derivative of v is. And just handle them individually. Make life easy. So, when I go down here, I can just take the derivative of this plus the derivative of the second term minus the derivative of the third term minus the derivative of the fourth term. I can handle them all individually when you're adding and subtracting. So, now that you guys are good at this chain rule stuff, what is the derivative of 5x cubed? 15x squared. Don't forget that's y prime, right? Plus, Ava, what's the derivative of 3x squared? 6x minus Alex, what's the derivative of 11x?
11.
It's 11. Because don't forget, this is a 1. 1 times 11 is 11, and then we can subtract 1 from that. I got 0 x's left. And Xavier, what's the derivative of 9? 0. It's constant. Right? Any constant is derivative of 0. Right? That's okay. Which means I really don't have to put this here. So my answer is this. Look how much easier that is. If I had to put this into the difference quotient, I'd have to put x plus h cubed times 5 plus 3 times x plus h squared minus 11 times x plus h minus 9. I'll subtract what f of x was, 5x.
So you would have solved that.
That would take a long time. Maybe just do that in college. Yes. Question, Irving. Okay. The product rule. These are very simple, so don't get confused. Don't overthink it. If I know you're looking at all these like, oh my goodness. Watch. Instead of saying the derivative of v is dv dx, if you want to say it's just v prime is the derivative of v, you can write it that way. It might be easier for you. What do I mean? If I'm multiplying two things together, two functions, okay? I take the first function as it is, u, and I leave it alone. And I multiply that times the derivative of the second function, times v prime. Plus the second function as it is, times the derivative of the first function. That's how you do any two functions being multiplied together. First, times the derivative of the second, plus the second, times the derivative of the first. And I have an example down here, because some of you guys are looking at it like you kind of understand it, but when we do the example, that's why I have examples with numbers. All right. Okay, so here we go. Let's say this is our first one and this is our second one. So if u is x squared plus 1, what is the derivative of u? So we just did something like this, a straight. Take the derivative of each one individually, right?
2x
It's 2x.
plus 0.
So this is 0, right? So it's 2x. Okay, so now what is b? b is x cubed plus 3. So what is the derivative of b? 3x. Stop it. Squared. And that's it. So now I take the first one, which is u, and multiply it times the derivative of b, plus the second one, b, times the derivative of u. That's it. So it's first times the derivative of the second, plus second times the derivative of the first. U is x squared plus 1. What's the derivative of b? 3x squared. Plus, what is b? Well, it's x cubed plus 3 times the derivative of u, which is 2x. Now I'll just clean this up. Let's clean that up. So that's the hard part. Just make sure you know which one is the derivative and which one you're multiplying. First times the derivative of the second, plus the second times the derivative of the first. You've got to multiply one times the other derivative. And then the second one times the other derivative. You see what I'm saying? Each one is multiplied by the other one's derivative, and you add them together. So, 3x to the fourth plus 3x squared plus 2x to the fourth plus 6x. And I just combine them. What can I combine there, people? What do I get? 5x to the fourth plus what's next? 3x squared plus what's next? 6x. There you go. That is the derivative of those two functions being multiplied together. That's what y prime is. Isn't that horrible? Isn't that horrible? Right? I think it's a heck of a lot easier. I'll clean that up. Here's the quotient rule, Alex, and we have a little saying to help memorize. Because you're going to see this and you're going to kind of freak out, but don't worry. Now, wait, before you write it, remember, let's say, instead of saying the derivative of u is this, we'll call this, I should do a u instead of a v. Let's call that u prime, and let's call this b prime. So when you write this, you're going to say b times u prime minus u times b prime all over b squared. Now, yes, you can do what I wrote in green. Now, there's a saying that I told the kids last year that I learned in college, and it's a rhyme and it helps. You ready? I'm assuming silence means yes. Okay. Low d high minus high d low. Draw a line and square below. So I take my low times the derivative of the high minus your high times the derivative of the low. Draw a line and square whatever's below. Now, if you reverse that, because the subtraction order matters, doesn't it? If I was to reverse the top, it would be wrong. Let's say I reverse the saying. I'd say high d low minus low d high, draw a line and square below. It doesn't rhyme. So it has to rhyme. Low d high minus high d low, draw a line and square below. So how do I do this one? All right. Here's my low. Here's my high. Right? So it is low x squared plus 1 times the derivative of the high, d high. What's the derivative of the high here? 2x minus high, which is this itself, x squared minus 1, d low. What's the derivative of the bottom? Draw a line and square whatever's below. So it's x squared plus 1 squared.
Let me write that.
Yeah, it's in the notes where you can write it down. Here we go. All right, so now I'm just going to simplify this. I'm going to distribute. So I've got 2x to the third plus 2x. Okay? Now, don't forget, a minus is to be distributed with a 2x. So it's like minus 2x is going to be distributed here. Because I have the minus with my 2x, right? So we've got minus 2x cubed plus 2x all over. Well, I'm not going to flow that yet. I'm going to leave that like that. X squared plus 1 squared. If I were to FOIL that, I would end up with, I have to do x plus 1 times x, or x squared plus 1 times x squared plus 1, and I have to FOIL it. I can't square both to the bottom. What happens to the top? Where? No, because it's a minus 2 that gets multiplied here. The minus 2x. Minus after minus is a plus. Okay? So, 2x cubed and negative 2x cubed cancel. And I have 2x plus 2x. That's 4x all over x squared plus 1 squared. That's fine. That is fine. All right? You want to impress me and pull that out? Go nuts. You sure? Great. All right. Numerical derivative. Okay, numerical derivative. Let's y equal uv. They want you to find y prime of 2, which means I need to figure out what y prime is and then throw in a 2. But the beautiful part of that is they give us everything we need to know right here. How do I find the derivative of something when I multiply two things together? What was the product rule? U times V prime plus V times U prime. And again, if this is y of 2, guess what? This is U of 2, this is V prime of 2, this is V of 2, and U prime of 2. Because they want to find y prime of 2. Okay? Why is it what? Because I want to find the y of 2, I just couldn't squeeze it in there. It should be like this. I just threw it in there after. Okay. So basically, all right, how do I do this? Well, I don't know what the function u is, but it tells me what's u of 2. So this is going to be 3 times what's v prime of 2? 2. Plus what's v of 2? 1 times what's u prime of 2? I mean, it doesn't get much easier than that. That's just understanding the product. How did I get 2? 6 plus negative 4? The answer is always 2. That wasn't too shabby.